The elytica simulation system extends beyond basic mine hauling and tramming simulation to create a true digital twin of a mining operation. It includes comprehensive features such as material tracking, equipment behavior modeling, and dynamic simulation of entire mining cycles. In addition to delivering accurate 3D animation outputs, the elytica simulation system provides insightful answers to key questions regarding production efficiency and system constraints. The primary use cases for the elytica simulation system include the ability to validate medium to short-term schedules, determining the optimal fleet size when maximizing equipment utilization, and using the detailed mining cycle outputs as a directive for in-shift tasking and dispatching. To demonstrate how the elytica simulation system extends beyond basic truck load and haul simulation, we will consider the following example. The blue node on the far left-hand side of the tramming network represents a tipping point. The red node represents a loading point at which a truck gets loaded by a loader. The green node represents a temporary storage area. The light purple node represents the source of the material from which the loader will load. The animation results show how loaders move material from the source node to a loading point, and how trucks move from the loading point to the tipping point. The limitation of this model is the inability to capture the increasing travel distance of a loader as development progresses further into the area. To address this, the material source node is removed and replaced with explicit links that represent development mining cycle activities. To model the continuous repetition of a mining cycle, each green link is divided up into parts that corresponds to a sequence of activities such as drilling, blasting, loading, and support installation. The simulation model will now dynamically adjust the source for the loader according to the progress of the development end. For this simulation run, we want to validate a schedule that was based on a fleet size comprising 4 trucks, 2 loaders, and 2 drill rigs. The effect of applying a dynamic simulation approach is demonstrated with the following output graph. Each bar represents the mining cycle time for completing all the mining cycle activities at a development end. The results show how the mining cycle time increases according to the increase of the loader's travel distance as development progresses deeper into the area. The next graph is the primary tool used in validating the feasibility of a schedule. It shows the cumulative tons trammed to the tipping point over time. If there is a large discrepancy between the tons of this graph versus the tons produced by a schedule, it highlights inaccuracies in the assumptions about the mining fleet size used to create a schedule. Next, to run the fleet optimization algorithm, the bounds on the fleet sizes of the trucks, loaders, and drill rigs are entered. The following graph facilitates the selection of an optimum fleet size. The blue line graph provides the total tons trammed to the tipping point. The green line graph shows the total fleet idle time. Each stacked bar corresponds to a fleet composition scenario. In other words, the number of trucks, loaders, and drill rigs. By moving the mouse from left to right, the effect on total tons and total idle times may be observed for an increase in fleet composition. For this example, the optimal fleet composition corresponds to scenario 6, showing that any further increase in fleet size will not result in any increase in tons throughput, and idle times will only get worse. Finally, we demonstrate how the elytica simulation system is used for tasking and dispatching by considering the following outputs. Each row of this compact Gantt chart shows the mining cycle activity schedule corresponding to a development end. Note that the loader loading times indicated by the grid activities are non-deterministic and are calculated based on the expected traffic conditions on the tramming routes. The dispatch instructions of the equipment that will support the mining cycle schedule are displayed by this graph. It shows, over time, what activity each of the pieces of equipment has to perform and when queuing may be expected as a result of traffic conditions.